our first meetup about the full stack deep learning course that we talked about last week. So we are starting today with lesson 1, 2, 3, and 3 is actually a bootcamp. And in the second part of the meetup, we're going to have the Mehul's presentation about the object detection. So let's start with the deep learning, full stack deep learning bootcamp. So how do you want to do it? We have it was like three videos, slides, and the lab code. I didn't do the lab code, but I hope Michael is in the meetup. Maybe I can maybe can show us how to do the code. So I will do it for next time. So did you guys learn anything interesting? I cannot hear anyone. Maybe it's my end. No, okay. So you have to unmute yourself first. If you want to talk, you have to unmute yourself first, because there was a huge background noise, so I've muted everyone. Can you see my screen, or is it?
Yes, we can see your screen.
Can you see the on the right hand side the page with the bootcamp, or is it? Can you see the full page?
Yes.
Okay, great. So it's cool. So yeah, so it's just to repeat what we talked last time. So this course, I'm just going through the page on the full stack deep learning course. So we have courses that teach us like theory or math or computer science behind deep learning. This is like the deep learning book or some other courses. And then we have like trainings that teach us how to train deep learning models. And I'm going to mute everyone again. If you want to talk, just unmute yourself. Yeah, so we have courses like Fast.ai, which some of us are familiar with. We have libraries like Keras or the deep learning AI courses. So in this sort of courses, we would learn how to train deep learning models so they train faster or to better accuracy, different architectures, and so on, so on. What was not included in those courses, at least Fast.ai, it's not, at least a little bit was covered in lesson 2 of part 1, how to deploy a web app recognizing some images. But this course, full stack deep learning, supposedly go through the full spectrum of what deep learning projects should contain. So it's from the data management, model training, model validation, and deployment. So that's what we're hopefully going to learn. And there's also so in that course, we have the videos. So each lecture has got a video. And also almost all of them got slides. So, and there is also a lab code. So it's on a GitHub and it's on a full stack. Stack deep learning. Yep. That's right. That's right. So we have also the lab code, which I've not been able to run. but hopefully Michael is with us today, so can help us to show, at least help me, how to do it for are you guys saying that my voice is too low? I don't know how to fix that. I'm sorry. I'll try to speak to a speaker here. Is it better now? Okay, thank you. Yeah, so that's the kind of like brief overview of the course. And for today, we hopefully watched lesson 1, lecture 1, which is introduction, and lecture 2, like about machine learning projects. And potentially we did also the lab code, and this is the this topic of the today's meetup. So I'm just going to open the discussion now. So if anyone wanted to share any interesting things that they've learned, any opinions or any issues, like from my end, like I didn't know how to run the lab code. Not that I spent too much time on it, but it's not really exactly as per videos, because they had some code, we don't have that code, and so on, so on. So we need to modify that thing a little bit to make it work. So if anyone wants to share their opinions, now that's the time to do it. And again, you have to unmute yourself because I have muted everyone. So sorry about that, but there was a background noise. That's why I did it.
I guess I don't. Can you hear me? I don't know.
Yes.
Okay. Yeah. Yeah. I definitely had a hard time getting everything set up, and took way too long to just get my system even set up. And so I don't know if other people encountered that sort of problem at all. But once you get it set up, it doesn't actually seem to be that difficult. The first tasks are pretty easy. It's just build the model and then run it. So
Okay.
in the video, he kind of goes through exactly what to do, and you have all the solutions too. So it's just kind of nice. I guess I had one question though, since some of my work mates and stuff prefer to use PyTorch versus Keras. And I was just wondering, like, how transferable are the Keras to PyTorch? Like, I guess all the theory is the same, right? It's just API is different.
Yeah, I guess so. I didn't really use TensorFlow that much. What I've learned was from my Jeremy and Fast.ai, that Fast.ai course, everything was in Python Fast.ai. I think you can use the open Onyx files, like you can move models around with that kind of like from TensorFlow to PyTorch, I hope, and to other languages, I think, other frameworks. But I've never used that one, so I'm not so sure. Let me try to take it. It's Onyx, I think. It's like
oh, sorry.
yeah, it's like an open format to represent deep learning models. So you should be able to move from one framework to another one. So PyTorch is there, and I'm not sure if, maybe, yeah. I don't see actually TensorFlow in it, actually. So I'm not so sure if you can transfer your PyTorch models to TensorFlow and the other way around. I'm not so sure. Seems like Cafe2, Microsoft, MXNet, PyTorch, and many other frameworks, but maybe if we read somewhere small print, then you can find it out, but not so sure.
That's okay.
Yeah. Does anyone know how to use different framework with that code, or like PyTorch instead of TensorFlow?
It's probably not a big deal.
Yeah, because that's also interesting for me to know as well. maybe for some other people, we are in this group most likely finished or doing some part of Fast.ai, which is mostly in PyTorch these days. And this lab is in TensorFlow, I believe. So I guess it will be easier for most of us to do this in PyTorch, if that's possible.
How much background in this does everybody have? Because I assume that we have a couple different levels of, I guess. I don't know. I'm brand new to this, so I just wondered.
I think Michael, would you be able to show us some how to run the code in this? In this meetup?
I'm not familiar with Zoom yet, but I try to share my. Okay. Okay. How do I share my screen? I guess
There should be.
Hand it over or something to me, or
you should see the share. It's either on a center bottom of your screen or the top. Depends if you have it full screen or not.
Yeah.
It's like a green share button.
Because I cannot share it because there's another user who is sharing.
Okay, so I'll stop sharing now.
I'll try. Okay, I'll try now again. Okay, that looks good. So let's see. Should I like start from the beginning? I posted this small how-to because I guess they really don't have it anywhere on their stuff. I mean, I was going through the. I will jump now around. I found it here then, and this is from the third lesson, the slides.
Okay.
You have the GitHub repo, and this is the code which was then important to get to the machine image and load it there. Let me see if I can switch now the screen. And with that, I was able. I tried two different things. Once I tried it on my personal machine. Okay, that's the wrong screen. And this was very tricky because I guess I'm just familiar with Conda, and they use this pip end. And with this, I guess it's a little bit different also from the because when you don't use this. Wait, I will copy it again. But I copied in the group on Slack. You have to specify the path there. I will show it immediately. So this is what I had to do to get it almost running. But the first script I was able to run, and you have.
We cannot see your screen, Michael.
Yeah.
For some reason. At least I cannot see.
Yeah. So, do you see it now?
Wait, are you running it on the same like virtual environment that they told you to do, or
I tried it with their environment, and there I could run more than on my Ubuntu machine.
Oh, okay.
So you start the notebooks on your local computer, right? And then you, in some way, you have to link the your Jupyter notebook to the weights and biases, right? Is that how it works?
No. I tried it. First, I tried it on the computer, like totally separated. But then I was running into problems. I guess one thing, this is even on their image on this weights and biases platform, is that there's problems with TensorFlow and all the operations which are maybe not working as they should. But with this weights and biases website, I could get it running.
Right. So you just started, enter that code from the slides, and then it worked.
then it worked there.
Okay, fantastic.
But I have it here. It's like on the lab 1 when you go into the repo, or it's even on the main.
Okay. I
page.
think we still see your screen with the weights and biases with the Jupyter Lab instance.
Okay, sorry. I have too much open now. Sorry, okay, that looks good. Okay, but it's, I will open it again. Do you see now my browser, or is it like?
We see something, I think,
Yeah.
but it's frozen for me at least.
Okay. So I'm now at the GitHub repo, but it's not showing, or?
No, I don't see it now.
Yeah, we just see the model and the summary of the model and where the training, the TensorFlow GPU device, that page.
Ah, okay. I guess then I have a problem with the other chat. But in the end, I will send you the link, maybe then.
Yeah, I think one of the problems with this thing is like when you share like say a PDF file, it only shares the PDF file. Then if you want to share the like a browser, you have to like stop sharing the PDF and pick the browser.
But now I'm not sharing anything, or do you see something?
Yeah, now nothing is being shared. Yeah, now we see the browser.
Okay. And then this is like the main repo page. And if you have a look there on the setup, this is like what you have to do in order to get a user. And then on this page, you can enter the code from the PDF. And with that, I'm not sure, do you see now the terminal again?
Yes.
Yes.
Okay. And then here, it starts the Jupyter Lab, which is quite similar to the Jupyter Notebook, and here you can then run it. And this is like you can open also the easy start, so you can just proceed around. Let's see. And this under one is also do you see now my screen?
Yeah, we see your lab 1 and then lab 1 solution and so on. So
Yeah.
how was the labs like? Is it hard, or I didn't get a chance to run, like for example like deeplearning.ai, like some of the exercises are quite easy. How did you feel this labs? Were they hard to do, or
I mean, I didn't look at the exercises yet, but it's I have to. What they have is like they have also some pieces left out. So most of the stuff is there. Is there.
uh-huh.
Okay, this is the bed. This is starting with left. And there, go inside. Look at the example. And then they have, it depends a little bit on the. So this is something. Do you see this? Like, with TensorFlow. Hello?
Yeah, I can just
So
looking.
this is so far how the assignments look like.
Okay, excellent. So
Up to part 3, and yeah, I mean, I guess it's more the focus is more on the how to handle that stuff and run it over the command line. And there they have on the repo also the code you can then try out and play with it. I hope you're seeing now the GitHub repo again. And there they have this.
Yes.
And with that, you can then start to play around a little bit, change the network type or the batch size, and also try the testing. This was also then working on the machine or on the cloud machine.
Okay.
Because I don't know, this pip environment was also not on there on this weights and biases machine.
Mm-hmm.
And I mean, we can try it now. It works then quite fast actually, because it's I guess a K80. We'll now stop that. This is also interesting. If you close it here on Jupyter Lab, I was not familiar, it can be still running here, so you can also run out of memory. So be sure to also close it here. And then it's simply you can start a new terminal. And then you see here that there's already the repo there. And then lab 2. And when we in lab 2, we can try it like this. So this is just the code from before. And then it's not working. And you see there's some of these like errors. But I mean, also the guy in the video had some of those.
Right.
But this runs them through. Yeah. I mean, I'm not familiar with TensorFlow on the level I'm with Fast.ai or PyTorch, so I'm also like would really enjoy it if we could try to put that in PyTorch or even TensorFlow, but I'm not sure if I can do that.
Yeah, it seems like they're not using notebooks for that at all. They just use the terminal.
Yeah, I mean, they have one notebook too, but this is like very, let's see where it is. It's just for looking at the data a little bit. It's not
Okay.
I will try to open it now. So it's not a big deal, yeah. So you have it here. So this works right out of the box. When I tried to put it in my Conda environment, I had to install a lot of additional stuff. But here you see it's like, yeah, it's downloads the data and you can have a look at it. But that's it from the notebook in the first 3 lessons.
Mm-hmm.
So it's more based on the command line. I guess here they also don't have one for lab number 3. Oh, there is one. Okay, this I haven't found yet.
Yeah.
Okay, that's the one from before, but there's another one. Okay. Try to have a look there. But this was also not in the video, this notebook, I guess. Maybe they show it on the 4th lesson or later. But yeah, it's just a look at the data for this line translation, I guess, yeah. Because you have here the string and then the recording picture. Yeah, I guess it's a little bit different setup than the Fast.ai course there, and it's quite dense, I guess, because it's just 2 days there or in these videos. Yeah, but that's all so far I had a look at. So I wasn't playing in detail with the code. And yeah.
Yeah, it's nice. I guess that kind of makes sense that once you have your model already, you don't really work in notebooks. That you kind of like execute your model from terminal. If I think about it, so maybe that's why they did it this way. Yeah. Okay.
I guess it's easier then if you have it set up like they have, that you really can change then easy
Yeah.
the parameters. And
Yeah.
I mean, I once run into problems in Jupyter Notebook when you like to have the output of the I don't know, the epochs in Fast.ai, and then it can get stuck, the Jupyter Notebook, because it gets too much strings sent to it. And interestingly, when you run it in the terminal, in the command line, it has no problem. So this would be also an advantage I could think of.
Yeah. And then in that lab, do they connect to the weights and biases or not yet? I don't think so.
This Jupyter lab is started from there, but I haven't seen anything yet that you send some training metrics there.
Yeah.
But I guess maybe that's later, because when I can try to open it, maybe we see. Let's see. Because when you open it there, okay, that's something else. And is it .com?
Yeah.
There you see also. Oh yeah.
Yes, we can see. Yeah.
There at least I saw something when I was signing up that there were some, yeah, quite similar, I guess, to Tensor. How's it called? The visualization from TensorFlow? Tensor. There's also a post in the Fast.ai forum, so it's quite similar to this Tensor visualization tool.
Mm-hmm.
I don't recall now, but I just looked up to lesson 3, and there they were not talking about that yet.
Okay. Okay, that's great. That's great. That's something for me to do next week. To do 2 labs in 1 week.
Yeah. No, I also still have to do the week 1 coding exercises. I still have to do it. I'm still thinking about if we can somehow transfer it easily to PyTorch, but I guess it will be not so easy and straightforward.
Mm-hmm. Yeah, I don't know how to do it, but I guess most of us are more familiar with PyTorch because this is most of us, I guess, did the Fast.ai course. And I missed that question from Anne that was about what's people's background. That's actually quite a good question. So thank you for asking that. Because indeed, it's I'm assuming that with most of us at least did some form of Fast.ai course, but that's not necessarily the case. So yeah, if you want to share about whether you do PyTorch, TensorFlow, anything else, or whether you're just starting with deep learning or you're experienced in it. So this course kind of assumes that you already got some knowledge about deep learning, and it kind of builds on that.
I mean, I started 2017 with this deeplearning.ai and then switched to Fast.ai, and yeah, that's where I am now actually. So we now like set up a local learning group and also get some people. And now recently I was looking more in the TWiML Slack group to find like-minded people.
Yeah.
And try to get more experience with hobby projects. So I work as a data scientist, but like very early, so to say. I'm not doing anything with deep learning related, more tabular data aggregation and stuff like this.
Excellent.
I'm brand new to this. I've been working through some of the Fast.ai like beginning course stuff, but it's hard to do it on my own. So I'm glad that this sort of group exists that I can ask questions and things. So, yeah, so I am brand new, have like almost zero knowledge and stuff. Yep, that's my background.
Excellent. Welcome. So we have some of us the So I think here at this group, we started with part 1. I was probably a year ago. I was probably summer last year when Sam started the study groups for the Fast.ai part 1. So then we finished part 1, and then I guess we repeated part 1 again, and then we did part 2 live. So that's what we just finished, and now we start in the full stack, which is going to take us 4 weeks or so. And after that, we're going to again think about what next for this group. But yeah, excellent, excellent. So it's just going back to the to that course a little bit more. I'm not going to go through all slides because there are a lot of them, but I hope I can open them at least. Right, so this is quite recent. Actually, it was run as Bootcamp. It was in March this year, so it's quite recent. It's run by 3 guys, plus some guest speakers. Yeah, the guest speakers, Jeremy Howard from Fast.ai also was as a guest speaker. And I had some introduction, what is deep learning? So like image recognitions, and took over the object detection very quickly. So now like the image recognition through neural nets is now like default way of recognizing images, whereas before it was different way, like OpenCV stuff. So the deep networks got many layers. Of course, the ImageNet is a good resource with like millions of images. And then what they showed is like the performance of the error rate really improved when the neural network were implemented. So that was big change. And then there's also image captioning thing, and a lot of stuff with the with a deep neural network. I think that's the first, if not the only one, still FDA approved, or maybe the other one. I think he mentioned that there's at least one, or maybe the one, FDA approved neural network in the medical industry. So that's a big thing because FDA approved that neural network can make decisions about patients. So that's a big thing. I don't remember which one that was because there are a couple of different examples, but there was one. Oh yeah, this is the one. FDA permits marketing an artificial intelligence-based device to detect certain diabetes-related eye problems. Right, and that's quite a big thing because usually the neural network is considered to be a black box, so you don't necessarily know what's going inside, and it's difficult to explain as well because if you have like 100 million of parameters inside a neural network, it's difficult to explain. I don't see chat now, so let me switch so I can see it, so I can see your questions. By the way, just stop me when, or just say anything you want. Let me see what's going on in the chat. I can see questions about like Slack channel for this group. So we are at the moment using the TWiML Slack and the Fast.ai channel. Is there any reason this course was picked up among any others? No, there wasn't any reason. We just were thinking which course to do next, and this seemed to be a good one. That's why we've picked that one, but we could have picked any other one as well. And someone mentioned that Apple's EKG monitoring was also FDA approved. That's a good question. So, Stefan, is it FDA approved for making the medical decision? Because I believe that the other one that they were talking about, this actually is making the medical decision as far as I'm aware. So the Apple Watch, is it like maybe just advice to the doctor? I don't know. I don't know. Maybe you can tell me if I'm wrong.
So I know for some, maybe somebody else has better info on this, but because I do a little bit of consulting work for people, and in my research, it seems like a lot of these deep learning things are mostly just for helping the doctor make assessments. So instead of the doctor looking through all of the images, or to combine two different sets of images. Since for like brain images, you can do CT, PET, and MRIs, and sometimes it's difficult to get all the information synthesized between the two, or between all the types of images. And so they use deep learning to mash them all together in some cases.
Yeah.
If somebody has other info, please talk about it.
Mm-hmm. Thank you. So like some people say they are not on our Slack. So if you want to be added to Slack, you need to go to TWiML website, and there is you need to ask for, so some will add you to Slack. Once you're on Slack, then just find the Fast.ai deep learning channel, and then you're there. So when I was talking about making medical decision, so you don't need a doctor to confirm that decision. So if neural network makes the decision whether you're healthy or you're ill, that's the decision. Whereas with the Apple Watch, I don't think that's the case, right? Even if it says that there's something like not fully right with your signals from about your heart, you still go to a doctor, and the doctor will make final call whether they need more tests or something. That's my understanding. Right, so if someone's got the general, so if someone's in a Slack and it's got general and meetup, that's fine. Just click on the channels, and then all the channels that on the Slack will be available. And then you just click on the one that you like to be part of. Yeah. Yes, I don't know. I don't know the details. Just going back to Apple, I don't know the details about the Apple Watch. I'm not going to talk about it. But yeah, that's a big thing. If I didn't investigate about what he was saying, that FDA approved this neural network, but for me it's a big thing because it's going to be more of those, and it's going to, of course, automate a lot of stuff and speed up a lot of stuff. But this uncertainty about the because neural network is a little bit of a black box, so you not necessarily know why it makes decisions. You can try to explain a little bit, but if it gets complex, if you get like 100 millions of parameters in your network, that's a bit difficult. So I think that's why I was thinking to myself, that's a big thing, the FDA approved neural network. So, but I didn't really do a deep dive on that. So I was thinking this was quite interesting about this one. Right, and he was talking about the autonomous vehicles, that it's a big thing as well, and a lot of companies trying to be on the market with that. Speech recognition with neural networks, machine translation. It's actually started a long time ago, 1950s, backpropagation, 1980s. The neural network, the convolutional neural network by Jan LeCun, 89. But all of that was not possible because the compute power was not enough, or there was not enough data. So now we have more and more computer power, and we have more and more data. Again, we talked about this. This course is more overview of the overall deep learning projects. So this, right. So they talked to a lot of companies about that do deep learning, and that's how they develop this course. So I think that's quite interesting because you can hear what's actually is being done by people that do deep learning. And they also talk a little bit about aspirations, about what in ideal scenario you would do with deep learning. So we talked about this a little bit. So we had 4 lab sessions and about 9 hours of video lectures and about 4 hours of the guest lectures. Of course, they use different Slack than ours. So if you want to be on our Slack, register online on the TWiML site, and then just join the Fast.ai deep learning channel. Are there any questions to the those slides? We still have discussion about the Apple or the other medical things. Oh, that's a different thing. Someone used GANs to make a picture, right? Painting, and then that picture was sold for a lot of money. And now is the question, who should get that money? So is that in relation to the using neural network in the medical space? Yes. So what are you saying, that the people who made the neural network will be liable for the wrong decisions, or? Oh, now if it's FDA approved. Well, FDA can, in my understanding, FDA can approve things, but they are not liable. FDA is never in fault, so they help you and they check you and they do things to make sure you comply with all the regulations. But if something goes wrong, even if it's approved, you're still responsible for your product. That's how FDA works, unfortunately, or fortunately. So the manufacturer is responsible for the product. It's not FDA. Okay. Yeah, and I don't know what to do next, because we have the lecture 2, which was like a lot more slides than that. How many slides? A lot, I think. I don't think we have time to go through all of those, at least not in a speed that would make any sense. So what are they talking about? Just maybe quickly. If anyone's got any from the lecture 2, any highlights from lecture 2, maybe we'll go this way instead of going page by page. Maybe we can just talk about it. And right, we have questions how we can find the course material, slides, lectures from Joseph. So Joseph, you can find them so there's this full stack deeplearning.com March 2019 as a page for that. And you'll find everything here actually. So the lectures and the slides are just below the videos. And is there also a GitHub link somewhere here? Possibly. But if not, then the GitHub link is here. Yeah, no worries. And I've posted that on the Slack, so that should be in the Slack as well. And maybe it's a good idea to start a new channel just for this course, so then everything will be in one place. Because at the moment we share with the Fast.ai channel, and that might be confusing. Yeah, so I've put.
Oh, Michael, I was wondering if anybody had gone through the first few lessons. Have you been able to get through one of the lessons or two or whatever? No.
Yeah, so the plan for this meetup was to go through lecture 1, 2, and 3. So lecture 1 is like overview. It's like a half-an-hour video about very generic about deep learning. The lecture 2 takes a bit more time. It's like an hour. No, it's actually an hour. And lecture 3, it's actually lab. So there's a GitHub repo with the code, and you can run that code. So that was the goal for today. I'm not sure actually how many people managed to do that. I didn't manage to run the code, so that's something I have to do for next week. But,
so what is the code? What is the first? What does the first code do?
With the code from the this lab, what I understand from what Michael showed, and Michael, correct me if I'm wrong, is that they showed what the code does. It's the recognizing text from handwritten notes line by line.
Okay.
It's I think, yeah. So you get a picture of some handwritten text. I hope you can see my screen.
Yes.
Yeah. So so that's kind of the project. So you get a picture of handwritten notes from a mobile, and then you get that to your app, and then your model should first of all detect lines, and then from those lines should detect the text. And so through the whole first 4 lab sessions, I think they're going to kind of make it work. But for this lab, it was introduction and setting up the Jupyter lab, and I think making the model work from the terminal. Yeah.
Yeah, I mean, I get the first thing was just a multi-layer perceptron. I guess that's really just there to show there's something doing, some fitting there. This is just like an example. You would never use it for this like final setup. And you start out with this extended MNIST, which has also characters next to numbers. And I guess, but this is just for the later stuff, is then I guess they want to set up an own network to do the line detection, which then feeds the detected lines to the line text recognizer, which is like then translating the text. But so far the code was like very, I guess, just low-level code that we have something to run and to show how you would like iterate and look at it. So I guess what we have seen up to the third lesson is nothing fancy at all, except that how you treat it with their setup. And
so is the idea just to build some simple model to do some simple task, and then to try to productionize it? Is that what the course is going to do?
I guess, but I guess they will also, the code will get more complex. I mean, in the lesson 3, they also talked about these CTC laws. This is also like more advanced stuff. So they have also some, yeah, they increase the the complexity. But I guess they can just cover this machine learning project pipeline. I guess they will not be able to go into detail with that stuff. They just then have some links on the slides. They have also this lecture 3 slides I posted now. It's linked to this article, which is very interesting, but this is like also very mathematical intense post. But I guess it's really to get going with the workflow also, because I guess it's quite different from like the Fast.ai notebook workflow.
I see. Yeah, so far I tried to get into the weights and biases, and I got an access code, and then I tried to set up the Jupyter notebook, but it said invalid access code. So I'm stuck there.
Okay.
Yeah, so some people have been able to run the code, to use the code, and it worked. Some people said, as you, that didn't work. I think we also are thinking that there's a way to start the Jupyter notebook or on your local computer, if that's the way you do it, on a Colab or on Kaggle, and then in some way, and just run the code. It's a TensorFlow code, so it's a bit different to what we've been learning in Fast.ai.
Yeah.
But so far, I wasn't able to find the time to do it. So
the code is just on GitHub, and we can find it there.
The code's in GitHub. Yeah.
Okay.
Yeah.
Okay, thank you.
Unless you're open it on this app.w&b.ai/profile there I was with the code, then there should be this instance opened with Jupyter Lab, but maybe it takes time. I guess some people already said it was kind of some minutes. I guess when it first started when I tried it, it also took a little bit longer, and then I guess it's maybe faster when you already have it.
Yes, I'm not so sure. I didn't expect this to work, this code, because, I guess they have to pay each time you start some sort of virtual machine or something, Jupyter Notebook instance. But if it works, it's better for us. So
yeah.
Yeah, I think you have to log in.
The tricky part is really that they use this pip and I guess most of the people are familiar with Conda, and then it's quite not straightforward to rewrite the stuff.
So the code we have is the so again, so if you go to the lab lecture, and I couldn't find slides for lab lecture. Where are they? Is it? We don't have those, right? Because we said.
I'm not sure if they have videos up from the lab on its own.
Oh no, this is the one. I'm wrong. It's there. Yeah. So this is the slides and the code here. So the code that I give it here, this is the code for the hub access. That code. Let's see. Yeah, there's access code. So in the weights and biases, they have this hub access pin. Is that the one?
This one worked for me, yeah. But I guess I also had.
Yeah, great. Yeah, so that's the one. That's the one.
Make sure you use an L and not an uppercase I.
Okay. So what's the plan for next week? Shall we give people some time and to do the first lap again, or shall we move forward and ask people to catch up and start with the lab sessions, second session for the lab?
Better to let people catch up, because otherwise you'll just be moving forward and no one will be with you.
Yeah, let's give some time to set this things up, right?
You said we need some time to set it up?
Yeah, we can talk back and forth on the Slack channel for people that have problems setting it up, and then the people that have already done it can help answer their questions, and then hopefully we can all be together by next week.
Yeah, so we had in Slack, that's the bit of agenda that I put together as a proposal. So we could stick to that. So today was the first 3 lectures. So the next week is lecture 4. That's the video. Lecture 5, that's a lab, second session, and lecture 6. So let's try to do that, and let's try to catch up.
The link to the schedule, maybe in the Slack channel or in the chat.
Yeah, sure. It's in a Slack, but it's here. So it's on top of the Fast.ai, but I'm going to copy and paste that to somewhere. Let's say to, where is that? Let's paste it here.
Thanks.
Okay, I think if we create the channel for this course, it's going to be easier to manage. I agree. So I'll do that. Yeah, it is pinned in a way that it's always there. So if you open the Fast.ai channel, this is the first thing you see here on top. So it's not pinned; it's actually in a description of the channel. So it's always here. Kind of hacky way, but it's there. Okay, let's do that then. So next week, couple more lectures and the second session of the lab, and there we'll see, maybe it gets more interesting in the lab. Do I have any more questions before we move to Mehul's presentation on object detection? I don't see any more questions on the chat. So Mehul, we start with your object detection.
Okay.
Which we were supposed to do last week, but we've run out of time.
Yeah, no problem.
Yeah, thank you. So I will stop sharing my screen now.
Okay. Hi everyone. Do you see a PDF with a summary called computer vision tasks?
Yes, we can see it.
Yes.
Okay, great. So while I was preparing for this, I just realized there's just so much stuff in object detection. I'm going to try. So what I'm going to try and do is give you like, okay, what are all the methods available, and then if there is more interest in the future, we can go drill down and deeper into methods. But okay, so why do we care about object detection? Let's say, so far, in a lot of the classes we have done classification. So for example, is there a cat in the object? Is there a car? Is there a pizza? Whatever, right? We just care about what object is there in the image. But there are a couple of things. So for example, the first one is semantic segmentation. So where what we are trying to do is, for each pixel, we are trying to give a class. So is this pixel a cat pixel? Is it a grass pixel? Is it a tree pixel? Or is it a sky pixel, right? So you're trying to give a label for each pixel. You're trying to give a class, and that is generally referred to as semantic segmentation. Okay. The next stage is there you have object detection, where you're trying to put a box around each object. So here you have 2 dogs and a cat. Okay, and And then the last thing is, so within the box, you also want to segment the object. So here you see the red. You have tried to segment the dog as carefully as you can. In red dog, green dog, and a blue cat. Okay, and so one thing I should say, I'm using slides from this lecture called from this class called CS 231. It's a Stanford class on computer vision, deep learning for computer vision, and it's only computer vision. It's actually one of my favorite classes because they talk about um, almost everything all the methods, and their lectures from 2017 are available on YouTube. These slides are from their 2019 lecture, which occurred actually 11 days ago on May 14th. So we have like sort of the freshest teaching material. Okay, so um, okay, I'll give you some intuition into how like people went about developing these methods, and then maybe in the last I'll talk. If you have there are questions, I can go through that. Okay, so here like I said, in semantic segmentation, you want to label each pixel, right? Whether it's a tree or a cow, sky or grass. Okay, so one way people could have done it is you take each pixel and you take a small patch around each pixel, and then you use the traditional classification. So you pass that patch to a CNN and then say, is it a cow or is it a cow or a grass? But of course there is a big limitation here, right? You have to extract a lot of patches, uh, and then you have to extract patches of different sizes. So you have a very high computation cost, and this is work actually from 2013 and 2014. Okay, so initially people tried it this way, but of course this is too intensive. So then it's very inefficient. Right? And mostly when you're using patches, when you're doing patches, uh, like patches that are overlapping will have similar convolution output, so you are not sharing features between the patches. So that was one thing. So the next approach after that was, let's do a fully convolutional. So basically we are just going to do um, take the whole image and apply convolutions to it, um, and in the end do some sort of uh, decision to say whether a pixel is a cow or a grass or whatever class it is. Okay, so you basically do so. That's why you will see things like fully convolutional. Okay, and then you make predictions. You are making predictions for all the pixel at once. Okay. But immediately you see there is a big disadvantage here. Because many times in these convolutions you increase the number of filters. So you start with say 16 filters, then you go to 32 filters, 64 filters, and you are doing it at the full resolution, which is in computationally intensive. Um, yeah. So okay. Yeah. So the next idea people came up with, and this is so initially we were in 2015, and this is the idea from 2000. Initially the first idea sliding window was 2013, and this idea is 2015, where they figured out, okay, you have this computational overload. Why don't I keep downsampling as I increase the number of filters? So you see the boxes become thicker here. Um, so you do this downsampling first, and then you can build it up, and then you can do upsampling to get back to the original resolution of the image. Um, so downsampling we are familiar with. It is is similar to the max pooling operation. Max pooling will do downsampling for you, um, but upsampling was new, right? So okay, and what the next few slides talk about is different ways to do upsampling, and I don't want to get into that because it's just a bunch of details about how to get back to the original resolution. Um, And like and they have like almost like different approaches. So they have a nearest neighbor, bed of nails, but we'll just get bogged down into details. But the basic idea is you have a 2x2 matrix and you want to go to a 4x4 matrix. So the nearest neighbor is just okay. Just take you just replicate this ones and twos this way, or they have a bed of nails approach, and people just tried out different things for upsampling. And they have some more details because it's the lecture, so they have a lot of details about uh, how to do the upsampling and some intuitive ways for it. Okay, so that was the idea of the idea from 2015. At, around the okay, but what this does is, so there's one limitation here, right? You can do the objects, you can classify objects, but there was no way with this method to put boxes around objects. Okay, so that's why um, there's a next category of methods called object detection, um, and they had so object detection has been around for 20 years. There's a recent paper which is summarizing object detection in the past 20 years, and they've reviewed like around 400 papers in this review paper. Okay, so why is so object detection is in, say, in biology, it's important in biology, it's important in self-driving cars, it's sort of everywhere. Okay. Okay, so so the first object detection problem was limited. Is that say there is only a single object in your image. So in this image there is a single cat, and so what they did is they have one one arm for classifying whether it's a cat or a dog, and that's the traditional convolutional neural network. And then the second, since I told you beforehand that there is only one object, so you just have to put one box, right? And so they have a second arm where you try to find the coordinates of the box, and you have two different losses. Like for the classification, you have a softmax loss, and for the box, there's an L2 loss. And basically, the idea was, okay, let's combine the two losses, and then you can do classification and localization. So that is put a box around this object. Okay. Okay. So that idea fails if I have multiple objects, right? So if I had one cat, it was fine. But if I have multiple objects, that idea doesn't work. And also, I don't know beforehand how many objects there are. So here there's 1, 3, and then you have so many ducks here, right? So you don't know beforehand how many objects there can be in the image. And okay, um, okay. So the first idea was. So now what I want to do is detect multiple objects in the image and put a box around them, right? So so one idea, what's the simplest thing you can do? You can take crops of this image. You can make different crops from this image, and then pass it through a convolutional network and say, is it a dog, cat, or is it background? So because some places in the image you have nothing, right? So you need a background class. And so there is, okay, so if you do it this way, there is an immediate problem. Like you have to take a lot of crops. So you have to take a lot of crops, and also objects may be of different sizes, right? You have a big dog or you have a small duck. So you have to take boxes of um, like different scale and at different locations. So this becomes, yeah, see, they're based, and you have to move the box all around the image. So you have like thousands and thousands of boxes, okay, and boxes of different size. So at different locations, scales. Oh yeah, and of course I forgot aspect ratio, right? Say you have a giraffe, so you have a very tall box, or you have or you have a soccer ball, so then you have a square box, right? So this becomes very computationally intensive if you try to do this box approach. That is, just take, like if you try to do it this way, take crops of the image and pass it through the convolutional network, you have too many boxes to go through, and it's too intensive. Okay. So one of the first ideas people, so this was before deep learning. They had this idea of selective search. That is, find me the blobbiest regions, or find me region proposals where there could potentially be a box, where there could potentially be some object. Okay. So there's one method called selective search, which runs in about few seconds on a CPU, and it will generate, say, 2000 regions of interest. Okay, like this. So you see some objects. So you see some of them are of, you have different aspect ratios, different scales, and different locations. So those are the three things to remember, like locations, scales, and location scales and aspect ratios. So think of giraffe versus soccer ball. Okay. Okay. So then there is this guy, Robert Grishik. When he was doing his graduate school work at Berkeley, he developed this method called it. So we have seen CNN before in the Fast.ai class or deep learning class. So what he developed was the regional CNN. He called it RCNN. Okay. And after this one, I'll stop for questions and then let's see. So basically, the idea is we don't want to do all possible boxes in the image. So he used like a region of like the selective search method and get 2000 boxes. Scale all of them to like a fixed size of 224 by 224, and then pass them through a convolutional neural network. So from this part onwards, you see that this is what we have done before, right? We have taken images and passed it through a CNN. When he did it, this was 2014. So he actually took the output of the convolution CNN, and he didn't have a fully connected layer. He just passed it. He passed it through a different machine learning technique called support vector machines, and yeah, he took the features of the convnet and did two things, like a bounding box and a support vector machine. So in the end, what you get is you're saying what class are you, and you also try to predict the coordinates of the bounding box. So you need 4 numbers, x, y, width, and height. Okay. So immediately you see the problem here. It's like it's very slow because you are passing. You're going to get 2000 proposals, and each of them you're going to wrap it to 224 by 224 and then pass it through convnets. So you had RCNN, and the next idea was. So somebody, I think their same group had the idea, hey, maybe I should switch these two operations. Okay, and this was primarily because I think the original method was too slow. I think they said something like, for a single image in 2015, in 2014 or 15, it took them 84 hours. So then they decided to make it faster, and here you see on the right hand side is the slow RCNN method, and here you see the modification. So they first did the convolutional network, and then did the region of proposals on the output of the convolutional network. And from there onwards, it was similar. It was a CNN, and they didn't have a SVM, but they could. I think they had a fully connected layer. We can look in the paper. But again, the two things, like which class are you and what box are you in. Okay. Okay, I will talk about one more thing and then maybe stop for questions. So, okay, so this is deep learning. the region of interest proposals, as I said, it is non-deep learning. It was traditional image processing. It was based on this one method was selective search. Um, okay, and I think here they had stuff about crop plus resize. So this step was quite. This step has some details like. Because I'm short on time. I'm rushing through it, but there is a couple of this is the important step. This is like a little bit tricky. So it's the original was I don't know if I have time to go through. There is a ROI pooling, but in this case they have if you they have ROI aligned basically to get a better positioning of the box. Okay. And I just don't have time to go through that equation. Okay. So one thing they noticed is so you can see in 1 year the improvement in 2014 it was about 84 hours to train the RCNN, and by 2015 they brought it down to 8 hours. This is using the fast RCNN, and in the architecture the main difference was like let me get that. It's just this. You swap you do the convnet first, and then you do the region of interest proposals, and they just swap those two steps. Okay, I think I'll stop for questions. I have more material, but I didn't check the chat. Yeah.
So you mentioned that there is this support vector machine applied afterwards. I just read that in the first MNIST experiments, they actually used a support vector machine for image classification. And my question is, how does that then work? I just recently conceptualized how it works with a CNN, because you can use every pixel as basically an input. How would you do that with a support vector machine?
So let's say whatever your output of the convnet is, because the support vector machine takes a feature vector, so they just take the output of the convnet and put it as a feature vector and feed it to the support vector machine. So let's say your feature vector might be say 4096. It's just a vector of 4096 values.
No, I see. Okay, yeah.
Okay, yeah. But this is quite old. I just wanted to give you guys the history of like how we got here, and actually there's a very interesting. Let me see if I still have it. Yeah. So this is the current state of the art. Like they on the y-axis, on the x-axis is the GPU time. Shoot, they don't have units, and on the y-axis is the accuracy, and they have all these different methods like for so if you are doing object detection, and if accuracy is the main goal, then you try one of these fast RCNN or faster RCNN methods on this side. But if you really care, but you don't care about accuracy as much, and you really want a speed, then there is another set of object detection methods. They call them like there is YOLO, there is SSD. So I thought this graph. This is from 2017 at a computer vision conference. So depending on your application, you can pick different object detection methods. And maybe I have a slide. I think I have a slide in about the difference between these high performance versus like high accuracy versus quick, like a speed versus accuracy trade-offs, right?
On the y-axis, we see overall MAP. I've also seen that in the full stack deep learning course. Can you maybe allude to what's the difference between this evaluation metric and, say, for example, the area under the curve in a receiver operating characteristic?
Yeah, that's a great question. I was trying to prepare before my talk. So MAP is a mean average precision, and it comes from, we are used to in ROC we are used to sensitivity and specificity.
Right,
Um,
right.
but in the computer vision and computer science side, they have precision and recall, right? And I don't know if anyone else knows the MAP very well, but basically it's like you have a okay, so we are doing object detection, right? So let's say you have the actual uh, mask of the object and your prediction. Let's say if you have perfect segmentation, right? You have complete overlap. Um, so if you do the intersection over the union, you will get a value of 1. Um, and but most of the times you will not have perfect overlap. You will have, say, 50% overlap or 60% overlap. um, so you pick a threshold, like, okay, let me say I got 50% overlap, and I'm going to call that a successful detection, right? I did not detect the cat fully, but I got 50% overlap between the actual and mine. um, and then you do it at 50%, 60%, 70%, and you get uh, a precision for like, I think, each IOU, and it's a mean. There's a mean average precision across IOUs. So that's a metric they're using in object detection. Sorry, I didn't explain it well, but I will share a
No,
link.
it's good. Yeah,
Okay.
I was just wondering if precision and recall is just CS speak for sensitivity and specificity, but I just Wikipedia'd it, and I think it's something else because let me get that here. Precision is called in statistical speak a positive predictive value, and the recall. Sorry, I didn't see it here, but yeah, it probably also has a more statistical terminology.
Yeah, and I think somebody did relationships between them, and then they have precision recall and F-score, so you will see that in a lot of these methods. Maybe one last thing, since I'm almost out of time, is yeah. So this was the, I was telling you about speed versus accuracy. So the in the earlier stage in fast RCN and faster RCN, and what we saw is we had region proposals, and we try to get the region proposals and then have a convolution and then try to do the classification. So in these single stage object detectors, what they did is they said, okay, I don't want to do all that. I just want to divide the image into 7 by 7 grids. Okay. And in each grid, I'm going to have a fixed number of boxes. So let's say I'm going to have, in this case, they have, I think they have 3 boxes of different sizes. So you see they have a tall box, a vertical box, a horizontal box, and a square box. Okay, and you could immediately say that, okay, why only these 3 sizes? If they, you could have more sizes, um, and then basically you have these. Say you had 7 by 7, and for each box you're trying to predict 5 numbers. Like you're trying to say, okay, is there? Say you had C classes, so you're trying to say, okay, is there a dog or a cat or background in that box? Um, and if it is a background object, then the X, Y, H, and W don't matter. Those are don't care. But if you are, say, 80% sure there's a dog in that class, then you would give the coordinates of the box. And so this is the, like, big picture. You have these single stage object detectors. These run really fast. you will hear about YOLO, Retina SSD, and RetinaNet. And actually, right now, RetinaNet is the most popular one. So that's why I think in the Fast.ai course, in the latest code, they have implemented RetinaNet. They didn't even bother to implement RCNN. It's just so old. You can implement it for just learning and understanding, but most people are just using RetinaNet nowadays, which came from this conference in 2017. Okay, I'm sorry, I'm just out of time, so I will stop here. But there's a lot of things I didn't discuss, like about like different object detection, and there's a lot of interest in this. For example, you know, like in self-driving cars, you want to detect, oh, is there a person that's come in front of my car, or is there another car? So all of that falls under object detection categories. We have in biology a lot of things like find the pneumonia in the X-ray, or segment the cells in microscopy. All of this comes under object detection. Okay, let's stop here.
Thank you, Mehul.
Yep.
Do you have
Thank
any
you, Mehul.
questions?
That was really interesting. Yeah.
Yeah.
So, would you say I've read about Fei Li? I think she's one of the best computer vision people in the entire world, right? Probably the best right now.
Yeah, she's really good, and it's their class. Yeah, if you see the notes, is she and some of her students have been doing this class for like the last 3-4 years, and they have really good notes. So I just showed you the lecture notes, but there's like they have a practical session on you know, okay, what are the practical challenges when you try to implement it or run existing methods. So they have a whole set of notes for that. Um, because right now, like PyTorch has its own implementation of these methods, and same for TensorFlow. These methods already exist. It's just understanding the theory, and then just trying them out for your application.
One could also immediately envision a military application, right? So if you think of autonomous drones, for example, flying over Afghanistan and so on, is something known there, whether these algorithms are also implemented there, or?
No, I don't know about that. I know like somebody tried to like Fei was at Google, and Google was trying to apply for a military contract, and a lot of people quit over that. They didn't want to be part of a military project. But that's all I know. I don't know more than that.
No, I think that that Google long ago abandoned the "Don't Be Evil" motto. You know that if you can think of these applications as, if you can immediately think of military applications, you know that are being pursued full steam at Google and other places.
Okay, great. Thanks, Mehul.
Okay.
So do you think you want to continue next week, or is that is there?
Yeah, I don't know if there's interest. Like there is a lot of material. Like maybe we can just look at code, and I've used this for lung pneumonia detection, and I've used it for a segmentation of microscopy cells.
That would be really interesting. I would be interested in that.
Yeah.
Okay. Yeah, and I have the code already. I can share the code if there is interest in that. Yeah.
It's fantastic.
Okay.
Can you share your presentation, by the way?
Sure. This is I just use Stanford slides, and I will share it in the Slack channel.
It was already shared in the chat, Michael. So if you have the transcript, you can probably post it in the Slack channel.
Yeah. Thank you. Okay, excellent. So we'll continue next week with the full stack deep learning lectures 4, 5, and 6, and with the object detection code by Mehul. So fantastic. Excellent. So see you all next week.
Okay, see you next week. Yeah.